We're going to start talking about now an observational study versus an experiment. Okay. The main difference in these two is in an observational study, we do not have any influence on the individual's responses. In an observational study, we are passive observers. We simply sit back, watch what happens, and record. Okay, so we have no interaction. We do not try to influence the responses in any way, shape, or form. We simply sit back and observe what happens. Versus an experiment. In an experiment, we deliberately impose a treatment. That's the key to what makes something an experiment. If a treatment is imposed upon the individuals, then we are conducting an experiment. If we do not deliberately impose a treatment on the individuals, then it's simply an observational study. Very, very important that you understand the difference. The big key here is treatment makes it an experiment. If there is not a treatment, it cannot be an experiment. Okay. In any observational study or in any experiment, we're always trying to talk cause and effect. The whole point to this unit is to say the explanatory variable X caused these changes in the response variable Y. If you think back to last unit in regression, we said that the explanatory variable had a relationship with the response variable, but we weren't necessarily able to talk cause and effect. Our favorite sentence from unit 3 was correlation does not imply causation. The only way to talk causation is through a properly designed experiment. So just like last chapter, we have an explanatory variable X and a response variable Y. We are trying to measure the outcome, the response variable, based on the changes in the explanatory variable. Remember, in regression, we were only able to look at 2 variables at a time. Explanatory, response. Certainly there are other factors involved here. And another variable that we can't really look at in a study such as this is what we're going to call a confounding variable. Okay? A confounding variable would be a outside variable that's mixed up with the explanatory variable. Oftentimes there's more than one reason for a change in individuals. Okay? When we're looking at a cause and effect relationship, explanatory variable is causing changes in response variable. Oftentimes there's extra or other variables that are also causing changes, which we would call confounding variables. When we have 2 variables that are confounded, we don't know what's happening. Remember, the explanatory variable X and the response variable Y. We'll call this other variable Z. Okay? So sometimes X causes changes in Y. Sometimes Z also causes changes in Y. So if the explanatory variable X and the extra lurking variable Z are both causing changes in the response variable Y, then we would say we are confounded. We're not sure, is X causing the changes in Y? Is Z causing the changes in Y? Are they both causing the changes in Y? So confounding is another problem when we're trying to conduct experiments. We need the language of experiments. When we impose a specific condition upon the individual, that's what the treatment is. The treatment is, what are we doing to the individual? And in this case, in an experiment, we will call the individuals an experimental unit. The experimental unit is the object to which the treatment is being assigned to. if these experimental units are humans, instead of calling them experimental units, we'll call them subjects. Seems kind of cold to say, hey, you unit, get over here. But you can say these people are the subjects of our experiment. But if they're anything other than humans, we will call them experimental units. Within an experiment, there's often different types or different types of treatments that are being given. Okay. So in an experiment, we will oftentimes have factors as well as levels. For example, we're trying to find a new headache remedy. So we'll say, oh, we're going to test Excedrin and Tylenol. Okay. So the factor is the variable that is being manipulated to cause the change. So in this case, the factor would be the type of headache medication. Did we give them Excedrin or did we give them Tylenol? That would be the factor. Okay? And sometimes within these factors, there are different levels. For example, the levels might be 200 milligrams, 300 milligrams, and 500 milligrams. And that would be the same for Tylenol. So the factor is the type of drug being given to the subjects. The levels would be the dose or the amount of the explanatory variable that's being given to the subjects. So these here would be the factors, and then this here, the different amounts would be the levels. So within an experiment, we may have different factors as well as levels.